Hello everyone, welcome once again to another machine learning related tutorial by Team Slidescope. In this video, you will learn how to use Randomforest Regressor to predict appliances electrical energy usage on the basis of different parameters that we have. We have temperature, sensor value, relative humidity, wind speed, atmospheric pressure, different type of conditions are there, and on the basis of that we will try to predict the electrical appliances energy usage in watt hour. You will learn how to do basic feature engineering here, how to drop unwanted features, and then how to import the models, how to do model selection, splitting the data set using random forest regressor, and for accuracy prediction, mean squared error and R2 score, and which feature affect energy usage most is something that we can predict using a simple bar H, where we have the feature names and importances we are finding from the model dot feature importances. So everything that is taught in that you are seeing here will be taught in this tutorial. So let's get started with it. So the data set basically contains information about date, number of appliances, and this appliances is in watt hour. So this is basically electrical energy consumed, and electrical energy consumed by lights, so by appliances and by lights in watt hour. Then we have T1 RH1, which is temperature sensors value, which is placed inside, and RH is relative humidity. So we have different sensors placed inside in different places. So these are T1, T2, T3 and so on. And we also have a temperature sensor which is placed outside, so which is recording temperature dates. We have pressure in mmHg, the atmospheric pressure, and this is relative humidity of outside. Wind speed, visibility, T dew point. Then this is some random variable 1, 2, which is added by the scientists for model optimization. Then we have these bins will not be present in the dataset because this is something that I just created while preparing a appliance energy analysis prediction dashboard in Power BI. So let's load the dataset in Google Colab and connect this file using Python Pandas and start analyzing it and preparing it for machine learning. So to get started, we have opened Google Colab here, and in Google Colab we have simply written our heading appliance electrical energy prediction with Python machine learning, and we have connected ourselves to Python 3 Google Compute Engine backend. First library that we will need is import pandas as PD, because this library will help us in importing the database. Now the file that we have here, the file that is UCI appliances energy prediction file, we will upload that file to our server here. To upload, we will click on this files, and from here we will upload this to this session. Remember, in the next session also you have to do the step. So you can see here the file is being uploaded. Once the file is uploaded, you can copy the path, and we will say df is equal to pd dot read underscore csv, and we will run this. So here you can see end of file inside a string starting at row 6901. So we have some issue here. Let me correct that. Now after loading it, obviously earlier it was causing some problems. Now it is loaded properly. You can see when we are writing df.head, so it is reading it properly. There is one more thing that we can do while reading a CSV file. We know that this date is actually date. or date time. So we can parse it at date. When you will load this, so it will not cause any kind of change, but when we will do df.info, so in that you can see it will be converted to a date time field, and in df.info you will see there are 19,735 entries from 0 to 1974, and all have non-null values. So this is very important for us. Now let's do some feature engineering here. So feature engineering, and for that we will use dfr is equal to, so the date column that we have, if you will write dot dt dot r, so this way we will get r, this way we will get day of the week. So it will create three new columns, and month, this way we will get month. So from the date parts, r, day of week and month can be obtained. And now when you will write df dot head, so you will be able to see these three columns also. So here you can see what is the r, what is the day of week, and what is the month. So this is first part of feature engineering. Remember, we have already done exploratory analysis. We have already found what variables are important. So for example, energy consumption by quarter and month, we can see month has effect on energy consumption. Energy consumption on inner temperature and outer temperature is also there, which tells us that this has little effect but some effect on the energy consumption. And energy consumption by the pressure in mmHg, that is given. So you can see for different pressure related values that we have created, a simple histogram has been created here. So we can see it is there. So after doing exploratory analysis, that's why we are considering these variables. So after doing some feature engineering, let's move ahead, and we will define the features as our target and input variables. So from our inputs we will drop date and appliances, because date we have already taken as our input, and appliances, date we have already taken into three parts: the month, hour, and day of week, and appliances is our target field. So we will create input and output like this, and to note we will call it defining features x and target y. Now this is an optional thing. We can drop the random variable 1 and 2 if not needed, so I am just going to drop them because these are just random variables. Next we will do the train test split. So in the data set you saw we have close to 20,000 entries, and what we are going to do, we will use 20% as test size. So using the train test split, we will create four variables. One is the training data x train, x test. So 20% of test values will be given to the x test data frame, and from y, that is our output, we will also keep y train and y test. So this way, if you will write x train dot test, so if you will write x train dot head, just you will see that we will get all the rows that we are using, and it will select some random values from our data set. Now we have the model, so we have the data set x train and y train. So we will train a model, we will use random forest here. In random forest, so in order to import random forest, you can do from scikit-learn.ensemble import random forest regressor, and from scikit-learn.metrics import mean squared error and R2 score. This will be for evaluation of our model. So here we will use random forest regressor. Number of estimators will be 100. So in random forest we use n number of estimators. So on this Medium article you can see In random forest classification, we have instances, and to create random forest, we create n number of trees. Every tree has some kind of output, and then based on the majority voting, we predict the final class. We are using the number of estimators that we are using here is 100. We are using regressor because all the values that are given here in the dataset are numerical values. Even the output that we have to predict is also continuous numerical value. So first we will create a model like this. Once the model is created, so in your model you can fit X train and Y train. That means your training data. And then, so this model will learn from the 80% training data that we have used, that we have created using the train test split. And then by prediction, that is appliances energy output prediction, will be created on the basis of all the testing values. So this will help us in testing our model's accuracy. So because we also have the actual values and we will have the predicted values. Now once the prediction has been done, you remember we imported mean squared error and R2 score. So R square score will be based on the tested values and predicted values, how many percentage of them are accurate, and the root mean square error will be created with mean squared error function, where we have to provide the y test and y predicted value, and we will use squared is equal to false here. So let's get rid of squared, sometime it's a problem. So here we have the root mean square value and R2 is score here. So based on the values that we got here, the R square is 4.559. This means that your model explains about 56% of the variation in appliance energy usage, and it's a moderate performance, not bad, but there is still a room to improve. And RMSE 4408 watt hour, this is the root mean squared error. It tells you how far off your predictions are on an average. So your model is off by 4408 watt hour predictions. Interpretation, the model captures some important patterns but misses quite a bit too. And you might improve performance by feature selection. So that's something we already did. You can try it by not removing them. You can try advanced models like SG Boost and feature scaling and tuning. Whatever we have done for feature importance, we will import matplotlib.pyplot as plt. Importances will be like this. So you can see R is very important here, month, week. So on the basis of this, T3 is important. So this, which feature affect energy uses most. So on the basis of this you can see, and then you can try to create the model with some important features also, and you will definitely see some improvement in your model prediction. But this is how you can do that. So this was a simple tutorial that was created for beginners who have just started learning machine learning. And with the help of simple tutorials like this, like you can do exploratory data analysis from here also. We have done some feature importance on our own. We can see by wind speed, by pressure, but some after doing this, you will understand what variables don't have any kind of effect, so you can drop them. By this we understood that month, hour and day of week were very important, so we created them. And then we used random forest regressor. You can also try different other algorithms and see how the performance goes. If you have any type of doubts, please let us know in the comment section. If you like this tutorial and want more Python, Pandas, machine learning, data analysis related, data science related tutorials, please subscribe to our channel, because every day we come up with some new data set and we explain both what is happening in that data set, and we will also explain the technical part of it from Python or Power BI point of view. Thanks for watching. Have a nice day.